we're going to think back to our different kinds of numbers that we've used in our mathematical life. So the first thing I want you to do is I want you to think back to kindergarten, or even before kindergarten, when you very first started dealing with numbers. Where did numbers start before you went to school? Where did they start when you were 2, 3, 4 years old? At 1. They started at 1. Even before they started at 0, they started at 1. And those numbers are called natural numbers. And so that's our first set of numbers that we learned how to work with. So those are called natural numbers. Then we went to preschool and kindergarten and we learned about the number 0. Okay? So then those numbers started at 0, 1, 2, 3. And anybody know what those are called? Whole numbers. Whole numbers. You learned how to add, subtract, multiply, divide, all those with whole numbers. Then somewhere probably 3rd or 4th grade, you started learning that whole numbers had opposites. And you probably started learning about those with temperature. And in Alabama, it doesn't get below 0 very often. Okay, but that's probably what you learned about, is that your numbers could be positive and they could be negative. And they were called whole numbers and their opposite. Anybody know what those are called? I think I heard it. Integers. Integers. Okay, so those are a whole nother set of numbers. Now, all of our natural numbers and whole numbers are in the set of integers. Okay, so they're all covered in those sets. After that, we started learning about everybody's favorite type of number, where we had to have common denominators to add and subtract, and they were parts of pizza and parts of a circle. Those are fractions and decimals. And that is where we hang out most of the time. So anything that can be represented as a fraction falls into this form of numbers. So it might be 3/2. It could be -1/4. It's going to be all of your repeating decimals and all of your terminating decimals. Okay, that just means they repeat or they stop. All of these are called rational numbers. And that is where you have spent most of your mathematical life, is in the set of numbers considered rational numbers. Okay, are rational numbers. Then at some point you learned about pi. And what do you know about pi? 3.14. And then what? Everything else. It keeps on going. It does not repeat, and it does not terminate. Okay? It doesn't repeat and it doesn't terminate. Then as you move in, I heard some of you talking about Math 112. As you move into Math 112, you're going to learn about a number called e. That is also an irrational number. And then today, we worked with some square roots where we had to do a decimal approximation. You remember how it was an approximate answer. That means it doesn't repeat. We had to round, and it doesn't terminate. These numbers are called irrational numbers, and pi is definitely the most famous irrational number. Okay? So all of these fall under this little category right here. Now, all natural numbers are whole numbers, all whole numbers are integers, and all integers are rational. So this is just an infinitely sized set of numbers that include everything in this set right here. Irrationals are kind of outside of that step because we can't represent them as a fraction. And if we take this entire set with all of our rational numbers and all of our irrational numbers, then we are set inside the set of real numbers, okay? And real numbers follow rules, and they have special rules. They show up on our coordinate plane. We are able to follow the rules of mathematics based on our real numbers, okay? And when you have no solution, when you get to a point where you have to say, well, there's no solution to this, it's because it does not fall into any of these numbers right here that are real, okay? When we say no solution, we are talking about this set of numbers. It means no real solution. So, what we're going to talk about today is we're going to talk about this set that is outside of real numbers. Okay? Outside of real numbers. That means it doesn't follow all the rules that real numbers follow. These are called imaginary numbers, and the most famous imaginary number is I. Okay? And that's what we're going to talk about today. That's what we're going to talk about today. Okay? Okay. So, let's get started on this. Imaginary numbers. Previously, when we encountered square roots of negative numbers in solving equations, we would say no real solution or not a real number. Sometimes you would also write that right there. A zero with a line through it means no real solution. And that is still true, okay? Because of the word real. Okay, what we're talking about today is not inside the real numbers set. It is outside of that. We are now introducing imaginary numbers, which includes the imaginary unit I. The imaginary unit I is the number whose square root is -1. So you actually want to have both of these close by when you're working on your homework. I is the square root of -1, and I squared is -1. Because if I take the square root of -I and square it, I get -1. So the fact that I squared is -1 is as important as I equals the square root of -1. Okay, so I want to make sure that you've got both of these, that you realize that both of those are important. Okay, so when we are dealing with a negative inside a square root, now a negative inside a cube root is okay, but when we have a negative inside a square root, we have been saying that this is no solution. And what that means is there is no real solution. So that's what that means, is there's no real solution. But we can rewrite this in terms of I. So I always take the I out first. I always have to do that. I always have to deal with the square root of -1. So I can rewrite this as I on the square root of 25. Okay, so when I take out this -1 from the square root, that's where the I comes from. Okay, now, can I solve square root of 25? What is it? 5. Okay, and then I'm left with my I. So the answer to this right here is 5I. I always have to pull the I out first. I always have to pull the I out first. Okay, so that's what I'm going to do right here. I'm going to pull that negative out. And when I pull out the square root of -1, I'm left with I on the square root of 32. So deal with the I first. Now, can I break 32 down? Good. So then I'm going to have I on the square root of 16 times 2. What's the square root of 16? 4. I've already got my I on the outside, so I have 4I on the square root of 2. So deal with your I first. Now, be very careful. Be very, very careful here, because this negative and this negative do not make a positive. This right here can be pulled out, but how's it pulled out? You're 100% correct. It's -1, so that's what this means right here. And then when I deal with this, I deal with that as I. Okay, so then I have -1 times I on the square root of 121. And actually, 121 is a perfect square. Anybody know what it is? What is it? 11. Good. So then I'm going to have -1 times I times 11. And so my final answer to that is going to be -11I. Okay? Can I move to the next one? Okay. When I multiply or divide, I must pull the I out first. Must. You must do that. You cannot multiply with the negative value still inside the square root. You must pull out the I first. You must do that. Okay? So before I multiply, I'm going to have I on the square root of 3 times I on the square root of 5. Okay, I must pull that I out first. Okay, what is I times I? I squared. Okay, and we'll deal with that I squared in just a second. Now, since I pulled that negative out and I've got I right here, can I go ahead and multiply the square root of 3 times the square root of 5? I can. What is that?
15.
Good. So it's going to be the square root of 15. Can I simplify the square root of 15 at all? No. But I can simplify I squared. What do we know I squared is? Negative. It's -1. Okay, so my final answer to this is going to be negative square root of 15. So that's what you've got to think about. You've got to pull this I out first. Then when I get I times I, and I'm left with I squared, you've got to turn that into -1. Okay? So for here, I'm going to deal with this first. I've got to get that I out. So I'm going to have I on the square root of 125 over the square root of 5. Now that I have this I out, is it okay to divide these two? It is, because they're both inside the square root. If they're both inside or both outside, you can divide. Okay? So I've got I on the square root. I divide both of these and I get 25. And what's the square root of 25? Good. So my final answer there is 5I. Okay. So that is our imaginary number I. Our imaginary number I. So now what we're going to do is we're going to talk about a complex number. A complex number is where I have a real number, which is this first whole number, integer, fraction, rational. So this is going to be a real number, this part. And this is going to be our imaginary part because the I is in it. Okay? A is the real number and the BI is the imaginary part. B is a coefficient in front of I. Now, we are going to add and subtract these the same way that we add and subtract like terms. Same exact way. Okay? So, what this means is if I've got A plus BI and C plus DI, Okay, I'm going to add my A and my C together because that's real. And then I'm going to have my BI and DI. I'm just going to add those together and keep the I. Okay, so just think about it the same way that you think about like terms when you're adding and subtracting. Multiplying will look a little different, but adding and subtracting, we're going to treat it the same way. Okay? So we are adding and subtracting like terms. And if you are subtracting, you must distribute. If subtracting, you must distribute. Okay? If you're subtracting, you must distribute. Okay. So, right here, I don't have anything that needs to be distributed, and I don't have anything in the inside that can be combined. So that means I can drop my parentheses. Okay? So I've got 4 and 3 that can be added together. What's 4 plus 3? Then I've got 6i and negative 2i. And what is that? 4i. Okay? Now this binomial does not have a real component with it. I just have minus 4i. So I've got 8 plus 2i minus 4i. Okay, 8 has nothing to be combined with. What's 2i minus 4i? Good. Negative 2i. Okay, now I want us to go ahead and do 3 plus 4i minus 4 minus 2i, just so we can look at how we have to distribute. We must distribute here. So we've got to distribute that negative. So this is going to be 3 plus 4i minus 4 plus 2i. Okay, because a negative negative is a what? Good. So then I'm going to have 3 minus 4. So is that negative 1? And then I've got 4i plus 2i. So what is that? Good. Okay. Okay, we're going to stop there.